Different loading scenarios are called load cases. For the swing set, we considered loading in the vertical and inclined configurations as two different load cases. In general, loading scenarios could be dead load, which is self-weight of the structure and weight of other immovable components. Live load, which for buildings could be the occupancy and for bridges could be vehicles. Wind load, snow load, earthquake, and so on. And with wind load itself, maybe there's wind in different directions. We may consider torsional effects. All this leads to different loading scenarios, and each one of these is a load case. We'll discuss these specific types of loads in much more detail going forward. Each loading scenario is associated with variability, so the loads cannot be estimated exactly. So load factors, numbers greater than 1, are used to account for this variability. Standards such as ASCE 7 for buildings and the AASHTO LRFD specifications for bridges specify load factors that have been constructed based on probabilistic analysis of the loads. Also, loads don't occur in isolation. So, for example, dead loads, live loads, and wind loads occur simultaneously. These are called load combinations. The extent of for our swing set, for example, one swing being in a vertical configuration and another swing being in an inclined position is an example of a load combination. The extent of variability when considering load combinations must be recognized because the worst case scenarios for all the load cases are unlikely to occur simultaneously. So to account for this, for example, ASCE 7 specifies some factored load combinations such as these. And we see one load combination is 1.4 times dead load, another load combination is 1.2 times dead load plus 1.6 times live load. These factored load combinations are used in connection with the strength limit state, and unfactored load combinations are used to assess serviceability.